Hi, good morning, and welcome everyone to today's session, which is Milliwatts to Value for Edge Impulse's Imagine Innovators. And thank you all for attending. We're thrilled to have you today. Before we begin, I just want to give you a little bit of housekeeping. If you have any questions during the presentation, please feel free to ask and we'll write them in the chat. We'll answer them in the chat as we can. We'll be monitoring the chat throughout the session. We will also have a dedicated Q&A segment at the end of the session. If you don't have an account with Edge Impulse already, please sign up. We will put a link in the description and in the chat, or you can go directly to studio.edgeimpulse.com. This way, you'll be able to follow along and create your own Edge AI models and put into practice what you learned today. Now let me get to the introduction. Our speaker for today is Vojislav. Vojislav is an accomplished embedded engineer in the tech industry. As an embedded engineering consultant at Edge Impulse, Vojislav helps integrate state-of-the-art machine learning technologies with a variety of silicon vendors' solutions. With his background in electrical and electronic engineering and a focus on efficient IoT solution development, he excels in overseeing embedded software projects and pioneering innovation using the existing hardware in open source research and production development. Now, let me hand you over to Vojislav. Thank you.
Thank you, Owen, for that introduction, and thank you all for coming for today's session. So, as Owen said, today's session is about how to turn devices into better version of themselves. The name is Edge AI Milliwatts to Value. So, essentially, how to make our devices work for us in a better way. So agenda is pretty short, but I think it would be interesting. So what we want to do today and show today is actually show a brief way of how we think when we build devices and think what we can do better in that sense, and then try to do it again, but build more intelligent device that can bring more value to the end user. So let's start first with the device. I did a lot of devices in my career, built them from scratch, changed them, modified them, and such. And it's usually the same pattern. We want to build something. We can take an interesting approach here with a door sensor. We want to figure out when the door is broken. What we want to do is to have a sensor which will send data when the door is moved. It's a short list of features saying this device needs to be battery powered. It needs to read a sensor value, usually some kind of motion sensor, and it needs to be connected to the cloud in some way to send data. After thinking about this, talking with a client and usual whatnots, we came to the conclusion, for example, that we're going to use Nordic semiconductor MCU for such device. We look at the range, for example, Nordic provides. Since we want to have this specific device connected over LTE network, we're going to go with cellular technology and 91 series from Nordic device, for example. Building such a device, and we're gonna take this standard approach with all the good practices that come with building IoT device. So we want to have it low power, being in low power mode, in sleep mode, being as efficient as we can, with connection, with the sensor readings, with device performance. On the other side, we want to have a good performance. So the chip we selected has a sufficient performance to execute these tasks in a fast way. We want to have this device secure, so there is no data leakage or such. And also, we want to have ease of use. I always see this as going two-way street. So ease of use for somebody who's developing that device, meaning we have a nice way of leveraging SDK and standard libraries for building such a device, but also ease of use for an end user when deploying such device. So it's a very simple process in engineering terms, but we end up with a device that actually has the same battery life as competition. We have device that has computing costs because every time the door is open, we're sending some motion data and we're analyzing that data in the cloud. And we're also ending up with a kind of costly connectivity bill. Again, for the same reason, because every time the door is moved, we're sending some amount of data to the cloud. And the real question is, how can we distinguish this device? How can we make it better, and how we can add value to the end users? So let's take the other approach, building an intelligent device. Intelligent. So how does that work? I like this slide a lot. It shows these two approaches in parallel, and we can see actually how we come to each outcome. Traditional programming that we just described and how we build devices, we're going to collect the data. Based on that data, we're going to create some rules and see the outcomes, and then iterate and adapt the rules based on the outcome and input data. It works nice and still works nice for a lot of devices and a broad range of use cases. But now with artificial intelligence, we can make things go around and work for us. So now we have data and we have desired outcomes, and we can make intelligent. We can break here. Sorry, we need to. I'll do this part again. So on the other side, we have artificial intelligence, and this new way and new approach of building devices such in a way that we have data and outcomes, and we can create these rules and iterate and make them better and better, which is much easier than putting fixed rules in our devices that are usually not well enough for a specific use case. So based on stuff we already built that already has in mind the privacy, the low power, and other important features and such, now we need to add additional stuff and layer on top of that, meaning energy efficiency in such way that we're not sending data maybe that often, bandwidth and latency, innovation, privacy, and other things that will make this device stand out. So how we can compare energy efficiency in such a way that it will make a big impact. For example, in our first case where we have this device that is done computing in the cloud, we need to send data more often and big chunks of data. But on the other side, we have this edge computing approach where we can compute that data on the device and send data only when we think that it's necessary. Let's describe this in a real world scenario. So since we are working with LTE data and we chose NRF91 series chip, here we can see a diagram of required energy to send a chunk of data. We can see here that actually sending data is just around 3% of the whole flow and the whole energy used for sending that data over to the cloud. A lot of it is actually packet stuff and that is needed so that the data ends up in the cloud. Here we can see actually how reducing amount of data we're sending is not really efficient compared to reducing intervals that we're sending at. Here, this graph, sorry, I need to do it again. So here we can see that reducing the data we're sending is not that efficient as reducing intervals we're sending at. For example, sending 2048 bytes will take about 1.82 milliamps instead of sending 1 byte will take just a bit less, 1.4 milliamps. But reducing that in time and the interval we're sending at, instead of sending one every 1 minute, if that is the frequency, for example, of our door that's opening, and sending that every 24 hours, for example, we can see a big reduction from, for example, 1.4 milliamps to 3.67 microamps, which is quite a lot. This means we can think of our device and create a logic on top of the ML model we want to build, that we want to send data, for example, once a day, if we see something that's malfunctioning. So how to do that, actually? So that this is where Edge Impulse, I think, comes in very nicely, since the whole flow with Edge Impulse Studio can allow engineers and people building products create these models in a kind of easy way, with less friction, and iterate and test them quickly. There's a set of tools that are, for example, provided from Edge Impulse, but also from our partners like Nordic, that enables engineers to iterate fast. So, for example, this is one I really like, is we can take this approach with Nordic device, for example, Thingy53, which can be connected to Edge Impulse Nordic app and collect data. Based on that data, we can develop a model. We can test it in the cloud. And with the same approach with application, we can deploy model right back into this device. And this can be used in a testing facility, for example, where the door manufacturer has their testing facilities, and validate the data, validate the anomalies, validate everything they need to create a good model. This closed loop is very quick and can be great for building such models. So after all that is done and tested, we can build our model with hardware in mind. Again, saying what we said, for example, Nordic is one of the Edge Impulse partners. So everything that is built from Edge Impulse is compatible with Nordic chips and MCUs. These also include things such as optimizing for RAM or optimizing for execution. Like mentioned, this app also provides ability to test, do live testing, and see the results right away in the application, and gives us ability to iterate quickly and have certainty that our model is performing well. This way, we can deploy to device with ease. So essentially, this application again gives us ability to do over-the-air update to, for example, in this case, Thingy53 device, and iterate, and see that our model is built well, and we can deploy directly to device. So at the point we validated that our model is good and performing well, we can adopt one of the firmwares we provide and are available freely in our GitHub account. They range for all the devices we support, Thingy53, Thingy91, which is maybe more suitable in our case for building a connected device over LTE, and edit that with our model and test it in the field as an MVP device. So after that, we want to maybe create some custom logic, or maybe add that model to our application that we already built. We can easily do that with deployment, with C++ library deployment, and just add that an SDK from Edge Impulse into our app. And from that, it's just simple as adding few configuration files. If we look at the Nordic SDK and how it's implemented, and calling run classifier with the right input to get the results we need. Based on that, we can create additional application logic and have device send data less frequently. So what have we built? Now we have built intelligent device that actually is more power efficient, that it's cheaper to maintain, that is also cheaper to operate. If we look at that, on top of that, if we add accurate fail predictions of the door, for example, in this case, we end up with added value device, which is actually something that's more desirable. With this, I would like to thank you. And yes, feel free to ask questions. I'm here to answer them.